Hi everyone, welcome back to my channel. Today we discuss about some problems related to the area of triangle and a parallelogram standing on the same base and in between same parallels. Okay, let's see the problem here. In this problem, let's see what is given. ABCD is a square and its perimeter is given at 40 cm and is the midpoint of the DC. Just check in the figure. Okay, here we need to find here the area of triangle EFC. Okay, since E is the median, now what happen if I join, like something D comma F? If we join, then what will happen? Let's see. When I join this line, then D in DFC, EF will become a median since E is the midpoint, right? And you know that median bisects the triangle, isn't it? So we use this property here. Now, in the solution in the first, let's find out the area of the square. And we have given the a perimeter, which we know that is a 4L. So let's keep the value of the perimeter. That's a 40, and that gives it 4L, and that's L is equal to 10 centimeter. Okay. Now with the help of the length of the side, we can find the area of the square, and that is L square, right? Now let's give the value of the length. That is 10. 10 square gives you the 100 square centimeter. Now we found the area of the square as as 100 square centimeter. Now look into the figure. You can see there the square and the triangle DFC are standing on the same base DC and in between parallels AF and DC, right? So we can say here area of triangle DFC is equal to 1 by 2 of A. A means area of the square. Why? Because it's a square and the triangle standing on the same base DC as well as in between the parallels AF and DC. Remember, square is also a kind of a parallelogram, right? So we can say this one. Now let's give the value here. 1 by 2 times 100. The area of the square is 100. So let's get the value here, 50 square centimeters. So what is the area of the triangle DFC? That is 50 square centimeter. Okay. Now we can use the median concept. Now we know EF median bisects the whole triangle. So we can just say like this. Area of triangle EFC is equal to half of A1. A1 means triangle DFC. So what's the reason? DF is a median. Okay. Now from here, we can just put the value here, 1 by 2 times 50, and that gives you to 25 square centimeter, which is the area of the triangle EFC. Okay, let's move to the next problem. Here you can see this figure here. Now see what's given here, okay? ABCD is a parallelogram. Okay, we are given this parallelogram. Okay, and here we need to prove that the triangle BEF is equal to triangle CDE. Okay, now just let me show you in the figure. These are the two triangles that we have to make them equal. Okay, now first of all, before in the solution, what we can do, let's look the figure once again. Can you see this triangle here, shaded part? Now we can see that this triangle standing on the base AB, and on the same AB, we can even see that parallelogram ABCD, right? So we can say in this situation, we can say parallelogram ABCD equals to twice of triangle ABF. Can we say this? Yes, of course. What's the reason? Parallelogram and a triangle standing on the same base AB and in between parallels AB and DF, right? Now, once again, let me show you something here. So we did say that one, okay? Now look at this figure, once again in the same figure, right? This is a triangle, which you can see the standing on the base AD. And on the same base AD, parallelogram ABCD is also standing, right? So we can make a relation here. So this already we said parallelogram ABCD equals to twice of triangle AED. We can just say that parallelogram ABCD is equal to, now we can say it's a twice of triangle AED, right? Why? It's the same reason, parallelogram standing on the same base and in between same parallels, right? Now, next is parallelogram ABCD. Can we say this one also? It is a twice of triangle AB plus triangle DC, the remaining triangles, right? Why? Because it's a whole part exam. We can say from the fact two, we can say it's a whole part exam, right? Now, both are the parallelogram. What can we say next? Let's see. Twice of triangle ABF. If you compare the 1 and 3, we can say twice of triangle ABF is equal to twice of triangle ABE plus triangle DEC. We can just say from fact 1 and 3. Compare 1 and 3, both are equal to the parallelogram ABCD. So we can say this one. So that is ABF equals to triangle ABE plus triangle DEC. Okay, just remember ABF equals to triangle ABE plus triangle DEC. We proved that. Okay, now here one more thing that we just proved this one, triangle ABF equals to triangle ABE plus triangle DC. You can check in the figure, right? But we know that triangle ABF is equal to triangle ABE plus BF. It is divided into these two triangles, right? From the whole part exam. isn't it? Now, if you look into the 4 and 5, both are equal to the triangle ABF. So can we say this? Triangle ABE plus triangle BEF equals to triangle ABE plus triangle DEC from fact 4 and 5, isn't it? Now, here we have a common triangle AB is a common. So we can just remove this triangle from the both sides. So we can just say here now, the remaining triangle is triangle BEF equals to triangle DEC. Subtracting the triangle ABE from the both sides, right? So here it is proved, isn't it? Now, let's move to the next problem. Okay. This is another problem here. See, you are given here. Let's check the given. The triangle ABC is given, and here the P and Q are the midpoints, right, of AB and AC respectively. And RB any point here. Okay, before we proceed, and let me just show you that what we have to prove here. It's a triangle PQR. That's a small, you can see PQR. That is equal to the 1/4 of the triangle ABC. Okay, that's what we have to prove here. But before we proceed, let me recall the midpoint theorem. Can you see in the red figure that's a triangle ABC? And P and Q are the midpoints. And if you join midpoints there, P and Q, remember it's a midpoint theorem. PQ will be parallel to the BC, and PQ is the half of the BC. So that's concept we have to use it here. Okay. Now, before we proceed, since P and Q are the median, now we can have some construction here. We can just join P and Q. Can we join like that? So what will happen when we join B and Q? BQ becomes a median. Remember, BQ is a median since Q is a midpoint, right? When we join the lines, then it will become a median, and median bisects a triangle. So using that concept, can we say this? Triangle ABQ equals to half of triangle ABC. Remember, concentrate on the triangle ABC, okay? ABQ equals to half of triangle ABC. The reason is BQ is a median. Okay, we have to concentrate on the triangle ABC. Now, we have to find the relation of the triangle ABQ. Okay, if you look into the ABQ triangle, you can see in that triangle, P is also the midpoint, and P and Q is already joined there. So can I say PQ is a median? If I say PQ is a median, median bisects the triangle ABQ, right? So we can see here, BPQ, look at the BPQ, that triangle is equal to half of ABQ. Can we say this or not? Yes, of course. Why? Because PQ is a median, isn't it? Now, so we can replace triangle ABQ, the value of triangle ABQ from fact 1. Look at that, okay? So we can say BPQ equals to 1/2, and triangle ABQ is a half of ABC. So I'm replacing this one. So 1/2 and 1/2 triangle ABC. So the reason is from facts 1 and 2. Just compare 1 and 2, we can replace it, right? Now, we can just say that is BPQ equals to 1/4 triangle ABC. Now, remember here, we have to prove triangle PQR. We have to make a relation with the PQR. So not a BPQ, okay? So we have to find the relation with the BPQ now. Now, if you look closely in the BPQ triangle there, okay? First of all, before we prove something here, let me show you something here. Can I say like this PQ is parallel to BR, or BC and BR is the same? So we can say PQ is parallel to BR. So reason is the midpoint theorem. So we can just say like this, P and Q are the midpoints of AB and AC respectively, right? We can say this, right? Okay, here we've already said this one. Now, due to the PQ is parallel to BC, now these are the parallel lines. Now look on the base PQ. Can you see in the base PQ? On the base PQ, you can see the two triangles BPQ and another is a PQR. So we can say here, triangle PQR equals to triangle BPQ. So what's the reason? Reason is triangles standing on the same base PQ and in between parallels PQ and BR, correct? So from here, what we can say now? We can say triangle PQR equals to 1/4 triangle ABC. Since from the facts 3 and 5, you compare the 3 and 5, okay? Because already we said that BPQ equals to 1/4 triangle ABC. So that's why we can say we can replace BPQ by triangle PQR. So hence it is proved, okay? So let's go for the next problem now. Okay. Let's see what is given here, okay? Here, the given is the P is the midpoint and R is any point. R is not a midpoint, remember, okay? P is just a midpoint. And here PQ is parallel to RC is given. Now we have to prove here the triangle BQR is equal to half of triangle ABC. Did you see the triangle BQR in the figure? Yes, of course, right? Now, let's join these 2 points, P and C. What will happen? Let's see, okay? The construction we can say just right here, C and P are joined, okay? When we join the P and CC, PC becomes the median. I already told you that when we join some line segment to the midpoint, it will become a median. And median bisects a triangle, remember, okay? And here we can say that triangle BPC is equal to half of triangle ABC, right? Since PC is the median, isn't it? Right? Okay. Now here we have to relate BPC with the triangle BQR because we need to prove BQR equals to half of triangle ABC, not BPC. Okay. Now before just showing the relation, now we can say that Q is the midpoint of BC. Do you remember the midpoint theorem from grade 9? Then when we just draw the lines parallel to the, one of the side and to the midpoint, then it will bisect the third side. So we can just write a reason here why the Q is the midpoint. It's a P is the midpoint and PQ is parallel to RC. Okay. That's why Q is the midpoint of PC. Now remember, since the Q is the midpoint, now PQ becomes the median again in the triangle BPC. So can I say this? Triangle PQC. Look at the triangle PQC. It is equal to half of triangle BPC since PQ is a median. Okay, since the PQ is a median. Okay, now here, one more thing we can see here. If you look here, we can say PQR is equal to triangle PQC because you see they are standing on the same base PQ and in between parallels PQ and RC. So we can write the same region here. Okay, so let's recall all these points once again up to what we have done. So let's see, we have done up to here. PQR equals to PQC. Have we done up to here? Now, once again, we can see here the triangle PQR equals to half of triangle BPC. Why? If you compare fact number 3 and 4, we can just say this one, right? We can replace PQC by PQR and we can say PQR equals to half of triangle BPC, isn't it? So we can write here from facts 3 and 4. Okay, I think up to here is clear. Now see, we can say here triangle BPQ plus triangle PQC equals to BPC. Can you see in the figure triangle BPC divided here into two triangles BPQ and PQC? So you can write the region as a whole part axiom, isn't it? Now here once again we can say here BPQ plus PQR equals to BPC because already we said PQR is equal to PQ. So we can replace PQC by PQR. So we can say the region here from facts 5, PQR equals to triangle PQC, isn't it? Now from here, what we can say, let's see. Triangle BPQ plus PQR equals to triangle BQR, isn't it? Yes, because we have already proved here. Okay, so what's the reason? Let's see what's the reason here. It's a whole part exam. See, if you look at the BQR, the triangle BQR, look at it closely, the BQR, it is divided in two parts. So it is a triangle BPQ and triangle PQR, isn't it? Yes. Now, since if you look at the 7 and 8, right, we can from 7 and 8, what can we say? We can say triangle BQR equals to triangle BPC. So we have made the BPC and BQR equal. Okay. And already we said in the number 1 fact that BPC is half of triangle ABC. Now, if we compare 1 and 9, what we can say in 10, okay, it is from fact 7 and 8, you can say that, okay, they are equal. From 7 and 8, BQR equals to BPC. Now, we can see here BQR equals to half of triangle ABC. Why? Because if you look at fact number 1 and fact number 9, we can replace BPC by triangle BQR. So in this way, we can prove that BQR equals to half of triangle ABC. I think it's clear, right?